Welcome to Spring LIB.
It turns out in doing part A of this problem, you'll actually end up doing part B as well. Part A asks for the average acceleration between time is equal to 5 seconds and time is equal to 0 seconds. The formula for the average acceleration would be the acceleration at 5 seconds in this case, minus the acceleration at 0 seconds over the time difference, which is just 5 minus 0. To figure out what these values are, we need to differentiate the velocity with respect to time to get the acceleration with respect to time. And we get the alpha goes away, and we get 2 beta times time. Now we can figure out what the values are. A of 5 is equal to 10 beta. And then plugging in our value of beta, which is 0.1, we just get 1 meter per second squared. A of 0 is equal to 0 meters per second squared. These are actually the answers to part B of the problem, but we need them to calculate part A of the problem. We can just plug in these, and we get 1 minus 0 over 5. And so the average acceleration for the trip is 1/5, or 0.2 meters per second squared. And so that's parts A and B down. Part C asks for graphs of V and A versus T for time ranging from 0 to 5 seconds. And so we can start with the velocity. So if this is V and that is T, we know that it's going to have a parabolic shape because of this form, alpha plus beta t squared. If we plug in t is equal to 0, we get that the velocity is equal to alpha. So this point here is alpha. Alpha is 3 meters per second, so that's 3 meters per second. At this point, it's going to curve up like a standard parabola until it reaches 5 seconds. And that's the only range that we really care about. At this point, we can figure out the new velocity value by going back here and plugging in t is equal to 5 seconds. If we square 5, we get 25. So 25 times beta plus alpha ends up being 5.5 meters per second. And so this y value is 5.5 meters per second. In order to calculate the acceleration, we refer back to this. A of t is equal to 2 beta t. So at t is equal to 0, a is equal to 0. And so this is a point on the graph. And we only care about 0 to 5, so I'm going to go ahead and put in 5 for my t. I should write a here. So when t is equal to 5, a is equal to 10 times beta, which is equal to 1 meter per second squared. So if I put that point, that is 1 meter per second squared. To get the points in between, we just simply note that this is a linear line. So it's just going to be straight. And so those are the two graphs, one of V versus T, and then the other of A versus T. One's a parabola, the other is just a standard line. And you'll note that this is the derivative of this parabola, which makes sense with what the acceleration is with respect to the velocity.